good morning, and thank you all for joining to what promises to be a fascinating workshop on emerging technologies and the war on terrorism. I'm Liav Orgad. I'm a senior researcher here at the ICT and the director of CTEC, the European University Institute in Florence. Our workshop today is pretty unique because emerging technologies which are characterizing the so-called fourth industrial revolution, they fundamentally alter the warfare and also the fight against terrorism. Now, the scale of this transformation is still unknown. It's still a puzzle, but the direction is pretty clear. New technologies are already blurring the line between the physical and the digital, the local and the global. And the goal of this workshop is to address the challenges, but also the opportunities that new technologies such as AI, blockchain, machine learning, deep learning, pose to both terrorists and decision makers. In a sense, the extent to which new technologies are used by groups to spread terrorism, but also by state organizations in order to fight terrorism. And the workshop is part of a larger project here at the ICT on that explore the intersection between new technologies, and terrorism. Just to give you one example, last year the ICT published a novel and yet a very alarming study on the use of Bitcoin and other cryptocurrencies by terrorist group. And today's workshop invites all of us to think out of the box, to question the contemporary understanding of the war on terrorism, and to reflect on new directions to prevent it, as well as some legal and ethical dilemmas involved in these new directions. I said the workshop is unique, not just because of the topic, but also because of the speakers. We put together global thinkers, both academics and practitioners, and giving the speakers experience, it promised to be a productive and inspiring workshop. The first speaker is actually my co-chair, Dr. Jennifer Woodard. Jennifer is the founder and the CEO of Insikt Intelligence. This is an AI startup based in Barcelona that is able to detect criminal activities, criminal content in real time based on digital sources, including, of course, social media. Insikt assists law enforcement and counter-terrorism agencies to fight radicalization and spread of terrorism. But Jennifer is, she's not only an entrepreneur, but also a highly respected academic. She's the vice chair of the European Commission Marie Curie Fellowship Program. I got Marie Curie about a few years ago, so I appreciate it even more. So without further ado, Jennifer, the floor is yours.
Thank you. Speaking to you? Yes, please. And to do the slides like this? Yeah.
I will stick in the middle.
Okay, all right. Yeah, that's fine. Hi, good morning, everyone. I'm here to talk to you a little bit about artificial intelligence in the very broad sense and some of the techniques that we are employing these days to detect terrorism and radicalization online in real time with our company and kind of the work that we're doing for law enforcement across the world. I wanted to start with this, actually it's a little bit cut off, but I wanted to start with this quote from our friend Mark Zuckerberg of Facebook, obviously. When he's sitting before Congress, he said, you know, as we sit here, 99% of ISIS and Al-Qaeda content is taken down from Facebook almost before any users see it. And I was wondering if you think that's true. I can tell you that it's not true. If it were true, we wouldn't have the problem that we have. So obviously, that's a slight exaggeration. What I do agree with Mark Zuckerberg is that AI is going to be a very powerful tool for combating this type of content. he says that in 10 years, AI will be able to detect in real time linguistic nuances that will help us detect terrorism and radical content online. That's actually a little bit too pessimistic, I would say, because we're kind of already doing that. Obviously, you can't be completely sure. Obviously, there's got to be manual intervention in these types of technologies, but we're actually developing algorithms today as a small company that is capable of doing this. So I'm going to talk to you about that. Sorry, my computer just froze a little bit. So I do believe that AI is our best weapon in terms of countering terrorism in the big data world. Obviously, we have billions of Facebook messages published every day, billions also of Twitter messages, and then we have also lots of other forums and websites, Telegram, other channels that are being used for propaganda purposes and for plotting terrorist attacks. So how does law enforcement actually get their hands around this? It's really, really hard. So we work with European law enforcement agencies that are quite large, and even these large agencies do not have the resources to be constantly reading messages. They often don't have Arabic language speaking analysts to look at the messages. So what we want to do is help them with artificial intelligence tools that will help them kind of cut to the chase and cut through all of the noise. I think that many people are kind of skeptical of AI still. There's a lot of critics that say that even human beings aren't able to fully distinguish what is, legitimate content and what is kind of threatening content. But what we're trying to do is basically teach machines to have some sort of a criteria for doing this, and then having humans step in later, whether that be law enforcement or the social media companies who would be trying to take down this content. So what can we do with AI? I think obviously we can use it to detect terrorist-related content, but one of the things that we're trying to do with some of the projects that we're working on is that we want to detect future threats early to be able to mitigate them. So detection of unknown agents, unknown users, unknown content. So law enforcement obviously, has their watch list. They're looking at people. They know who they're looking at, but what is it that they're not looking at? Who do they not know? That's what we're trying to extract using artificial intelligence. And also the prevention of radicalization. So it's not just threatening messages online or content that's very blatant. It's very subtle kind of signals of people that are being pulled into radicalization processes, which obviously if we attack this early using these types of tools, we can intervene. So I don't know how much you guys know about AI. It's a very, very broad term. I wanted to talk a little bit about some of the methods that we're using to do this, and I've kind of left it at a very high level, kind of superficial, and then later, if you want to talk about actually how this is done, how we build these tools, how it works, so you can kind of get a sense of that, we can talk about that maybe in the second part of the workshop. So you may have heard about natural language processing. Natural language processing basically is a form of AI that helps computers understand what we're telling them. You use natural language processing every day when you do a Google search. That's probably the best way of describing it. And what's it useful for in terms of counterterrorism on social media or in digital sources is that it's useful for finding information in large bodies of text without manual intervention, meaning you don't have to read all of these messages. The computer is actually doing it for you. So basically it's telling you, look at this message, look at this other message, and this is highly relevant for what we want to do. And part of NLP is text mining. So text mining is an automated process that it's basically for deriving what we call high quality information from text-based messages. So text mining basically goes beyond monitoring keywords. So in the past, what law enforcement intelligence analysts have done is basically they'll monitor a hashtag or monitor someone's name and see if it comes up on social media. That's basically very reactive because you have to know what you're looking for. Text mining goes beyond that to get you deeper information and kind of derive meaning from the messages as if a human were reading it. So they would be able to pick up on nuances that maybe a keyword search would not. So it's pretty helpful for that. And then when we talk about what high quality information is that we're getting from text mining methods, basically, you can get suspicious content pointing to criminal behavior. Like I said before, it may not be incredibly blatant content, but it could have, little signals that could be useful for you to understand what's going on. Propaganda, radical content, hate speech, also information about users. There's, later we'll probably talk about this, but obviously there's some privacy, civil liberties aspects that come up when we talk about user information. But actually the examples I'm providing here basically are coming from public data sources. You can also understand the relationship between users, so who they interact with, how they talk to each other, how their groups are conformed. We also like to pick up on trending information that could point to anomalies. So for instance, if suddenly there's a hashtag that is trending or a spike in content production, suddenly lots of people are tweeting about a certain thing or from a certain location, you could probably come to the conclusion that there's something going on that's a little bit fishy. So I'm sure you've also all heard of machine learning. So machine learning obviously is something that's kind of popular. It's a buzzword these days. So it's the science of getting computers to act without being explicitly programmed. So we're trying to emulate basically human thought by teaching the machine to learn from different patterns. So this for us is really useful because we want to teach computers how to spot radical or terrorist-related content, so we don't have to do that ourselves. So you can imagine that that would save a lot of work for law enforcement. And how it works, it almost works as if like you teach a child. So you're going to feed the machine learning algorithms lots of information, from forums, from blogs, magazines, websites, known content, and you're going to develop a training set. One of the challenges that we face in developing these types of technologies is that we don't have enough data. Data scarcity is a huge, huge issue. We don't have enough data because this type of data lies in the hands of law enforcement. Oftentimes it's classified, so it's not something that a private company who's developing information systems like we are actually has access to. Luckily, we've worked hand in hand with law enforcement, also with the ICT, who has a lot of domain expertise and some data sets to be able to train our system on real life cases. So basically, just very superficially, what you would do is you have a non-supervised data set would consist of, in this case, is an example from jihadi text. You would feed that into some vector models. Then we have supervised data, which is online content, which we have annotated with information about basically scoring, whether or not this is a suspicious piece of content or if it's not a suspicious piece of content. And then we would develop the patterns from that supervised data in order to be able to, for future data, be tagged as being suspicious or not suspicious. You can stop me if you have questions. So, in the case of suspicious content on Twitter, monitoring social media for suspicious content is really, really challenging. Keyword searches aren't really able to locate this type of content, so you're probably missing 90% of what's out there due to the fact that keywords change, slang changes, jargon changes, hashtags are really dynamic as well. What we have to do in these cases is we have to update our systems and teach the system, okay, well now this means that, or this means this. And this is also extremely challenging because the nature of the internet is that it's highly dynamic and ever changing. So in the examples you see on the screen, this type of content if you're using just a strictly keyword-based approach, it's probably pretty hard to identify. If these users were not on your watch list, you wouldn't be able to pick them out because this person happens to be saying, we have more, hashtag Manchester Arena. That means nothing to me. It means something to us now because we know what happened in the Manchester Arena, but these were signals that were being put out there that were going undetected because they don't have any specific linguistic markers or anything that could actually tell you that this was suspect content. So, if you're following things like hashtags, related to ISIS, that's great, but it's not necessarily going to give you the type of information that you are looking for. It's 90% of the time you're going to get, news sources or official sources. What you're looking for are these kind of hidden pieces of information, like needle in a haystack. So where it really gets good is when you combine text mining with machine learning. So what you're going to do is you're going to teach the system to understand and detect patterns. So basically you're telling the system, when you see this and you see this, it's this. And that's a huge shortcut for law enforcement in detecting this type of content. Like I said, there are many different ways of kind of putting the pieces together, but that's kind of the gist of it. Machine learning is teaching the system to understand and to detect future content. Sorry. So again, in this case, what we would be doing is we were taking known suspicious messages. Like I said before, the case of getting data is a little bit tricky, but if we have a large data set, we are going to feed it into the machine learning module, and we're going to basically assign a threat or suspiciousness score to the future messages. So, when these messages pop up in the system, you're able to know that they should be looked at. And obviously, there's something we call recall in kind of our industry. It's how many times you actually pick up a document that is worthy of looking at. And then there's, accuracy rates as well, and they of course vary. And this gets better and better as you feed the system with more and more use cases. Also challenging is that you start with an approach that is supervised, and you're actually probably focusing only on one specific domain. So if we're talking about Islamic terrorism, we're building models that are built to understand about the ways people speak in the domain of Islamic terrorism. But if we wanted to deal with hate speech, we could do that, but we would we'd start again with a new data set and training the data set to understand those types of use cases as well. So, the more messages the machine learning model is taking in, the better it's getting at detecting suspicious content and classifying it. So it's not just about detecting this and saying this is suspicious. We also want to put it on some sort of a spectrum. So if law enforcement is using a tool, they may want to know when something's a 5, but they don't care if it's a 2. So we have a threat spectrum of 0 to 5 in terms of what you should be definitely looking at, or what you might want to take into consideration, or some messages you might want to put on your watch list. So this is just a quick example of kind of the output of a system that's looking for jihadi messages. Really all it's showing you here is basically the words that are being used by the users in their messages. I don't think this is actually from an English data set, but we mostly work on Arabic data sets. But you can see by volume and by kind of relationship between the words, what the conversation, or the direction of the conversation. And like I said, you have different use cases for this. It doesn't necessarily have to always be related to terrorism. We've worked in the area of detecting hate speech. So you can see here at the bottom, we have different categories for detecting hate speech. So it's race, behavior, physical impediments or physical attributes, sexual orientation, et cetera, et cetera. So basically, we're using the same mechanisms that we would be using for generating the analysis on ISIS messages as for just kind of generalized hate speech. And something kind of completely different, but I think is really relevant, is social network analysis. So this is basically, it's a process of investigating social structures through the use of networks and graph theory. And this is actually something that precedes the existence of social media. It became highly interesting to look at in the case of the 9/11 attacks. That's when we started looking at SNA related to kind of terrorist cells, and this was in the offline realm. We are incorporating it and combining it with text mining techniques to understand the relationships between users online. And it's really useful for identifying new suspects. So law enforcement, they tend to know who they're looking at. But isn't it interesting to kind of understand who they're interacting with? And you don't always get that without kind of an algorithm to do that for you. So, we are using it to understand the organization of terrorist suspects, the relationships online, how they interact with each other, the types of things that they're talking about. And there are several ways of going about that. So you can actually detect the interactions within a number of groups using machine learning. It's unsupervised. I think one of the things that is really interesting for us to look at is the way content spreads as well. So in the realm of propaganda, obviously, the speed at which it spreads, the communities that it affects, social network analysis is something that you can really use to do that. Also mapping the connections between users. So this is something that we did on an ISIS Twitter conversation network. So we've identified 109,567 nodes. So those are all users, and 187,566 edges. So the edges are the connections that the users have between each other. So that means they're either retweeting each other, they're mentioning each other, they're mentioning each other, and the conversations that they're having, obviously you can drill down and to see. This is a data visualization that's generated by, as a result of the algorithm, but what you would ultimately want to do is drill down and see, okay, this person's talking to this person, and they are talking about this, and they're talking about this at this time, and then this other person's retweeting it. So obviously the expertise of law enforcement, when they have this type of information, is going to help kind of make this more useful and more applicable to real-life situations. It's also really useful for looking at thought leaders. So sometimes online, actually, in the conference yesterday, we were talking about, I think Rita from Site was talking about the way kind of the groups are organized online. And sometimes it's hard to tell kind of who's leading the charge in terms of spreading the propaganda or spreading the content. It's really easy to do with an algorithm like this. So we can actually see who the thought leaders are. So in this case, you can see the larger nodes. Those are picturing the top author according to the degree of citations of other users. So basically, it's other people that are mentioning this person, or they're retweeting their content, or they're having some sort of interaction with them. And sometimes these faraway nodes actually can be more suspicious than the ones that are closer to the author themselves, is what we found. So again, suspiciousness also of users. This type of mapping is really useful. Understanding interactions. We do this with something we call a suspicious cluster. So we would create a suspicious cluster by identifying users with suspicious content and that interact with each other. And a user can be considered more suspicious if he or she is interacting in a certain way with a suspicious cluster. So for instance, directly communicating with members of the cluster rather than just retweeting. If they're speaking directly to someone who is an influential user in one of these clusters, they're probably more suspicious than someone who's just kind of reactively retweeting. Are we doing okay on time? So the same applies. We take the known suspicious profiles, we would feed them into machine learning model, and then we would assign as we would with the content, a threat score or a suspiciousness score for these users. And then we would use these user profiles to later build the data set that would, again, feed and make the system a little bit more accurate. So if you have these types of users that have these types of keywords in their bios, they use these types of user profile pictures, they tend to tweet about these things, then we can kind of create like a persona that later we would use to further train the system. So this is kind of what we were talking about earlier, you know, determining the influence of a user in an online community. That's basically just, again, talking about kind of thought leadership. And also understanding what content is most popular. So we can do that obviously just with natural language processing, where you're kind of unearthing what everybody's talking about in volume. But what's also really interesting to do is to see how the conversations cluster together. So people who are using this hashtag are using this hashtag. You drill down and see who these people are. You understand a little bit more about what they're talking about, why this content is popular with them. And it's a very interesting way of discovering things that you didn't know about. Okay, there's something going on the ground that we didn't know about, and they're talking about it in a cluster. So it's very, very interesting. And you know, these are actually the top hashtags in a community of suspicious users in Arabic and English. And it's interesting how certain kind of content clusters together. You know, you'll see content that, you know, Syria and France in this case is clustered together. If you drill down, you would find out why. But it's a way of discovering content that you would probably not know about before otherwise. We also do this by relevance. So relevance is determined by a combination of different things. So citations, if the hashtag is a hub, the centrality of a hashtag. So this is really good for kind of uncovering new persons of interest. So if there's a hashtag that has a certain relevance number, you might want to look at who is actually using this hashtag. And this is obviously in the case of Twitter, but you can do this on other social networks as well. It wouldn't be hashtag, it would be a concept that they're using or topics that they're talking about. And then predictive analytics. Predictive analytics is also a very broad term, but basically what we're doing is taking techniques from data mining, statistics, and machine learning to analyze data to kind of predict what's going to happen in the future. And this sounds kind of, lots of people are very skeptical of this in the terrorism realm, and obviously it's very experimental. But what we would want to do is we'll take historical data, for instance, in the case of the Paris attacks, of everything that was tweeted in Paris that day. Start looking for, patterns, anomalies, and train the system to kind of be able to identify a certain scenario in which this is happening again in the future. So what we want to do is gauge the potential threat level for terrorist attacks by attempting to predict these actions. So say at a certain time of day, these users or a community of users in this location are suddenly tweeting, millions of tweets or hundreds of thousands of tweets. There's a lot of chatter. This could potentially point to an anomaly. Obviously, it's dangerous to rely on something like this. You're not gonna, call in the armed forces based on one of these alerts, but it is something that, law enforcement can have a closer look at if they start to see these types of trends. And that's this is actually just a visualization of our software that's basically showing the threshold for threats. So we have a 1 to 5 level of threats, and this is based on things like content production, the sentiment of the messages, the threat scores of the users. So we're combining all of that information together to kind of just give a potential threat score for a certain location in this case. Another interesting thing that we're doing is human behavior modeling. So our software is actually called Inviso. That's where the screenshot comes from. And what our software does is basically combines all of the methods that I just talked about into one piece of software that's going to help alert you to content that you should be interested in. What we're doing in terms of human behavior modeling is that we're working with the ICT and Professor Ganor. He has actually put together a model, a theoretical model, that places individuals on a spectrum of radicalization. So basically, he is taking a ton of data. He's saying, here's a real terrorist attack that's taken place. This is the trajectory that this terrorist has had throughout his career, let's say. And we're basically making algorithms that model this same type of a theoretical model. So what we want to do is be able to not just say, okay, this person is tweeting terrorist-related content, and 2 days before they commit a terrorist attack, actually detecting way in advance that this person is either becoming radicalized or is vulnerable to being radicalized. So we're able to kind of combat these things way before they actually happen. So we're hopeful that this will be something that we can implement on a commercial level, or at least at a pilot level. So we're going to be piloting this technology with several law enforcement agencies across Europe. And then another thing that we're working on that also kind of combines the things that we've talked about is that, so if you have text data, you have natural language processing that's working on that text data, you have machine learning, all of these things are contained kind of in the realm of the digital world. So what's happening outside is not really part of that. Everything is contained in social media, blog posts, forums. We kind of theorize that this isn't enough. So there are lots of other factors that are determinant in making someone become radical or vulnerable to radicalization. So what we're working on is a concept that basically takes kind of everything that we're already doing and then ingests other sorts of data sets. So for instance, we're talking about socio-demographic data, unemployment data, religious affiliation data, crime, weather, all sorts of open data sources to determine whether if this is actually something that we can kind of factor in predicting whether or not someone is going to be radicalized. The on-the-ground kind of equivalent of this is community policing. So I think Luke yesterday talked about this in the Lone Wolves panel. We're talking about how there are signals that if you are on the ground and looking and talking to, looking someone in the eye and talking to them on the ground, that you can pick up on that, systems or large-scale investigations cannot pick up on. So, is this person suffering some sort of personal crisis? Are they unemployed? Do they have problems? These things all factor in when we're trying to figure out whether or not someone is vulnerable to be radicalized. So this is again it's highly experimental, but we think that we can get somewhere with this. And it kind of takes everything to a different level, not just leaving it kind of in the social media and digital realm. And I think that's all I have for you today. I hope that was pretty superficial. If you guys want to talk about any of these aspects with me, kind of on a technological, or if you want to ask about the methodology, I'm here to do that. I wanted to introduce my colleague, Yaniv Azani. I say my colleague because we work on a project together related to these types of things. So Yaniv is the Chief Technology Officer at the National Cyber Crime Unit in the Israeli National Police. He manages the technological aspects of criminal investigations and is in charge of developing systems in cyber law enforcement. He has rich experience in cyber operation and technological training at the IDF and the Police Academy. So welcome, Yaniv.
Thank you. Good morning, everyone. Actually, after hearing Jennifer, I think my work here is done. If you think you spoke very superficially, I'm going to talk in a higher level. As Jennifer said, I'm the CTO of the National Cyber Unit in the Israeli Police. I'll give some aspects of counterterrorism and technologies used by law enforcement and our challenges. The first thing for us, we identify several attributes for cyber actors in the cyber domain that are different from the physical domain that give them some advantages. As you can see, and probably you're familiar with most of them, the first one is globalization. So, okay, you can have several actors in different countries in the world. Some does not even have any diplomatic relationships, but the actors can connect, compare, coordinate, whatever they need. They are working in a different domain. Another challenge and another advantage that they have is military-grade weapons, as we call it, because cyber weapons are not the same as any other physical weapons that, for example, terrorists can acquire. Even if a terrorist today in the physical world can acquire a massive explosive missile, whatever it is, they don't have a jet fighters. But in the cyber world, whether it's cyber criminals or cyber terrorists, they can have weapons that were developed by countries that in some way, and you're probably familiar with some of the cases, were leaked to the internet in this way or another. So today, we as law enforcement and counter-terrorism agencies, we are facing terrorists that have actually military-grade weapons, okay? They can attack. They have a jet fighter, a cyber jet fighter in their hand, and that changes the game. Another good advantage that they somehow have is the anonymity that the network allows them. They don't need any physical access, okay? In the traditional way of terror actions, they need to go there. They need, if they want to make any terror action, they need to set the bomb in a specific way. They need to get into the scene, into the area. Today, if they want, the cyber terrorists, if they want to hit any critical infrastructure, they can do it from home, like any other hacker. That's another factor that changes everything. Encryption, whether it's for the data, the communication, whatever it is, give us, law enforcement, a lot of hard time in order to try to intercept, detect, identify whether the actors, their missions, or their entire plans. And another attribute is, as you probably know, cryptocurrency. We changed a lot of the way that we can, as law enforcement, can investigate things, even if before the event or post-event investigation, because even though cryptocurrency is more open, you can see all the data, sometimes you have the problem to link it to the real entities in the real world, which in the traditional investigation was a very helpful vector of investigation in order to track. Once you track the money, you can get the organization and the actors. Today in cryptocurrency, it's another challenge that we have. If we sum it all to the three main challenges that we have is, first of all, anonymity, as I said. And the second one is the massive volumes of data, okay? If we want to either predict, prevent, or even investigate, when we're talking about the cyber or the digital data that we have, it's massive volumes. There's no way law enforcement or any other governmental agency has the ability to analyze all the data, whether it's in real time, but not even in real time. Even if you want to analyze it later on, as a large going on investigation, you cannot do it manually, personally. You must have the right tools and the right technologies in order to do that. Whether it's data from social networks, social media, digital forensics. Today, if you want to, for example, I've seen the report on the Boston Marathon incident. Just the amount of data that they acquired from cell phones that were left in the area, in the scene, in order to analyze that, to get the basic artifacts, the basic information, you must have a different technology, of course, based on big data fusion, as we can see later. But also, if we are talking about cyber intelligence, whether it's a web int, as my colleagues are gonna show later, but any other cyber intelligence data that can come on, you must have different engines in order to analyze, investigate, and get the data that you want. And another challenge, as I said, is the cryptocurrency, that today sometimes it's more challenging to trace it back to the real actors. So as I said, the main thing that we understand that we have to do is the big data fusion. Whether it's social networks, digital forensics, today every simple investigation that involves like 5 actors, 5 involvers, we are talking about between 5 to 10 terabytes as a start. analyzing all that, whether it's computers, cell phones, or whatever it is, whatever digital information that you have, you must put it into several big data engines. It can be the Splunk, the Nuix, the analytics for cellular phones. We put that today, what we do, we put that through several big data fusion engines, and we get some filtering, screening of the data to get the link analysis to filter out some irrelevant data, which is most of the data, by the way, and to enrich the data that we already know. Another layer is, as Jennifer mentioned, most of it is the other more advanced tools, whether it's NLP and AI, SNA, and even complex event analysis for all the thing. Together it all, three main layers for us. As I said, the big data fusion give us the basic, we're taking the raw data as we see, because today the raw data is the massive data that we can analyze by ourselves, filtering out the irrelevant data. Above that, the enhanced tool that allows us to enrich the data to something more useful, to get the link analysis, to get the conclusion that today a human analyst cannot do. And above all that, implementing and applying artificial intelligence techniques that gives you the ability to identify things that you couldn't done before. For example, to identify new patterns, to realize new organizational behaviors. Today we have the ability with these tools to identify organizations that we didn't know that even exist. Okay, whether we're talking about criminal activity, whether we're talking about terror activity, from the social media, from the connection, even from the digital forensics, we had some investigations that we had the suspects, we knew the main actors, but once we took all the devices, put them in the big data fusion, just for the digital forensic, we found new actors. We actually found new and bigger organizations that were part of all the activity that we had no idea about that before. That we can do only with these tools. All these layers allow us for the main thing that we need. First we need real-time alerts. That's what we need, because today, as I said, it's impossible, and it's impossible to predict it by ourselves. And most of the activity, especially with some incidents that we saw here in Israel, the lone wolf, the individuals, attackers, you have less traditional intelligence that allows you to predict and prevent the incidents, and only these kind of tools can give you the advantage for real-time alert, knowing, okay, we've seen some Twitters, some tweets, we've seen some communication in the social network, okay, there's gonna be an attack, something that the traditional intelligence cannot give us today. And the other layer is, of course, get all this massive data for our human analysts to try and really have something to work with. As Jennifer mentioned, we are part, as a law enforcement agency, we are part of the Red Alert project of Horizon 2020, the European Union, this is the main thing that it's trying to do, to give us the real-time detection for predefined alert, online data mining and analysis in a way that hasn't been done yet. And another aspect, as I said, is the post-event investigation, because whether it's a real-time investigation, post-event, for example, if a terror action has occurred, you need to know very quickly more than the thing that you got on the scene. Even if you have the suspect, you know his communication, sometimes you don't know who are the other actors. You don't know if there's going to be a second wave of attack in the next few hours. Okay, you don't know what is the infrastructure that he used to coordinate and plan these attacks. And once you use this tool for investigation, not prediction, not prevention, you have the ability to explore and resolve many other aspects of this organization that you couldn't do before. So this is another part of this project that was very quickly, very superficial. Thank you very much.
Okay, thank you. Before I will introduce briefly our next speaker, just three points to bring into the agenda. One is that the two first presentation, you both talked on how ways of using emerging technology to combat terrorism, and I wonder whether we can bring maybe later into the table how terrorists are using those technologies so the other way around. Second, I'm very much curious about whether we have some data on the outcome, how effective, about the effectiveness of the system. And then the third question is just to kind of zoom out on the effectiveness issue. And later I want to bring in some legal issues and ethical dilemmas, which of course are involved on those situations, and maybe some anecdote too. So the third speaker is David Karpf. I can't say much about him, so I can just say that he's the head of the AI Center at the Minister of Defense in Israel. I assume that the title says much more. Thank you.
Back? Good? Yes, good. Very intimate room. So, I'm David, as I was introduced. Welcome. Oh, you have to record? Just as I prefer not anyway. So, we'll put it here. I hope it will work for you. For the people who come abroad, welcome to the hottest week in 2008 in Israel. Hope you have a good time here. My presentation will show you, I will discuss a little bit in high level about AI, then we'll dive into some use case that I've worked with. So first, just we'll be on the same page. What is data science? So data science contains three parts. Contains the first part that probably familiar to all of you, will be the trivial ones. It contains the field of computer science, then the field of math and statistics, but the surprising third element is that I call it subject matter experts, which means it can be any field that is out there in the world, in the academy, and that's what makes data science applicable to every part of our lives. Now, you probably heard that the AI race, some call it the Cold War 2.0. All the leading giants, all the companies are there. Just a table that I just found on the internet of the top 10 companies in the States, their investments and the acquisitions in the past 5 years, and that's only the public ones. So you can see how they see it. And then, of course, you have President Putin and Google's CEO that talk about AI, that who will rule AI by 2030, will rule the world, and that's why it's a tough race that everyone should get their acts together to be there. Just for example, few examples of how AI changes our lives. I just read a few months ago, insurance company in China decides if the bank will give you a loan only by automatically interviewing you 5 minutes from your phone, asking questions and seeing the little tweaks in the person's face, seeing if he's lying or not lying, and that's how it decides if the person can be trusty. That's one example. Of course, you can take it to the smart homes, autonomous cars that take us everywhere, invite what we don't even know we are lack of in the fridge, or what we probably will want to eat for dinner, because we eat a lot of oil for lunch with fish and chips or something, so we probably want something healthy at night. So you can take it, of course, in the field of commercials. You probably already know that Facebook and all the Twitter, etc., listens and reads what we think of, what we want. Commercials are sewn to what we probably will click on. You can take it even further to what they're talking about, the new called the revolution of industry. 150 years ago, decided there should be a price for everything. Before, I don't remember exactly the year, but it's 1840 something, 47 maybe. Don't catch me on this word. Until then, how you price things was the merchant and the buyer would come together, and then they would discuss how much he was willing to pay for it. This was the comment. Then when one store became a chain, didn't have time for each person 10 minutes of arguing on the price, I decided to give a price for every product. For us, this is now trivial. We come to a store and there's a certain price, and it doesn't matter from where we come from, we pay the same price. But will it still be in a few years from now? Because with the AI, you can really adjust the price to the person for how much is willing to pay. Probably companies will take it to the highest price you can take from that person. And then you can talk about if it's ethical or not. You can say it's not ethical, which people will pay more. Maybe the contrary, it's very ethical. That people that doesn't have much income can go to universities or can buy things. Not only the rich will rule the world. So that's a few examples, and as Jennifer also and Yaniv showed you, of who controls AI can control the world. Machines will make decisions for us. For now, already you've seen few machine learning called machines that decides which job a person will get in the organization, or which person to accept to the engagement in the interview, and it's doing a much better job than a 45-minute interview that any person can make. So why now? We're talking about data science. What happened? I mean, we can maybe have this lecture 20 years ago. So I'll give you a short running time of what happened in the past 50, 60 years. The first neural network was introduced in 1947. I've studied it 20 years ago in my computer science degree. It's a cute course you have to take because it's something cute. It's only an academic, you can't really do anything with it, but you should know about it. Then came the multi-layer, what Yaniv mentioned at the deep learning. It started a neural network that contains few layers. Then came the big data, the internet, and then got one place that has a mass of information. It started with ImageNet that had one giant database of pictures. Then came the GPUs, the graphical processor units, and gave the aspect of hardware, because in order to run these neural networks, you couldn't do it on the computers that have been in just 10 years ago. The GPUs just by accident were taken to the AI because they were manufactured for gamers. You probably know that every gamer that wanted high speed and to work with have a great games, he will buy himself a GPU. And then we understand we can use it for AI. Then came the first neural network, the first deep learning in 2012, and came almost to the performance of human beings. Then it also in 2016 outpassed the human capability in certain challenge. Now that's in a brief history of AI as I see it. And now I want to discuss about a little bit from my experience and what I've seen in few organizations, and talk about the data science, call it soon data science next revolution. What we did after we understand that this data science is probably something we should look at, we established 3 years ago in the MOD, the Data Science Hub, where we brought all the organizations in the Ministry of Defense. We brought academia, the top companies that work in AI, and a few others to one, we call it in the beginning one lab. It became a hub, and we defined 3 roles, where there is a data scientist, the data engineer, and the data analyst. The data scientist is the person who comes from the academia, has first, second, or more degree. He deals mostly with algorithms and statistics. He is the math and statistics part in the first slide. So he's that guy. That engineers comes from the computer science area. And he's doing all the coding behind it. He's in charge of distributing all the algorithms so to be efficient and can run in a real time and not in a theoretical case. And he's really we defined the new job. You have to be a big data architect because in order to use this hardware and use these capabilities on this hardware, you have to. It's a subject by itself. And last but not the least comes the data analyst, which is the domain experts. He comes from his area. It can be economics, can be law, and every domain that you can think of. He brings the problem and the data. Now we established data science infrastructure, and I'll try to keep it high level, not to go too much in the details, and I'll explain to you how we do that, because that's like thing that changed my life or my perspective of how do we solve problems. Until then, how we solve problems? We had a problem saying I want to find something in somewhere. So the analyst would say, okay, in order to answer this question, I will divide it to a few answers and then answer each question separately. And what data science brings to the table is you don't need to know how to answer these questions. You just need to bring the data that is relevant, or even remotely relevant to this problem. You bring examples to teach the machine what is a true positive and what is a false positive, and let the machine itself find the features, I call it, or the elements that for that subject, and find the correct course of action that will give you the answer. So instead of, I'll give an example of how it works in the real life. Insurance companies have to give you life insurance, to give you to the building insurance of how to pay, and which premium, what the price of the premium should be for you. So until then, how would we do that? Have analysts and would think, okay, what is the features that has to be for that subject? So we'll take it we'll take it a little deeper. How do I price the premium for a building? I would check probably the age of the building, the neighborhood that it's stationed, maybe how close it to the ocean, right? Maybe there will be a flood or things like that, etc., etc. And all these features, until now, are used mostly by the insurance companies. Now, when we fed it into the machine worked for a few hours, and then the result was, it was in the United States, and the result was, someone has a guess? The Euclid distance from the closest fire department station. Why is that? Because when the insurance has to pay, is big bucks is when the building is called total loss, and as far as you from the fire station, then the chances for the building to survive is then between low to almost doesn't exist. After being said that, the insurance analyst said, okay, that sounds correct, but years of hundreds of analysts could not think about this feature. But the machine thought about it very quickly. Why? Because you fed all kinds of data into the machine. It was all the GIS, the geographical layers of how old is the building, how the roads, what is the closest gas station, etc., etc. All this information and the age of the persons and the people of the neighborhood, all that subjects. Then apply all kinds of different, call it games, mathematical games, and in the end found out this calls the feature extraction and modeling phase. And in the end, you have the answer, and the analyst can evaluate it. And sometimes you can say the machine is wrong because there is some problem in your data. For example, when we did in Israel, we saw that people that have asthma, say in English asthma, asthma, has what is it prepared to just to say this example, so we have some help with English. Long, sorry. Pneumonia. Thank you. Pneumonia. We'll have last chance to have pneumonia, and that sounds that. And you ask doctors, it doesn't make sense because these people are usually have the tendency to have more the pneumonia, but. Then we understand that because we know that they have a good chance to have it, so they are taking shots in the beginning. Every time they come to an hospital, even though they have just a headache, they put them with pills and medications to that won't have any pneumonia. So the machines also you have to have the data analyst to look at the result and say if you think they make sense or not. I'll give you an example then of after we established, it took us about 2 years to establish this, we call the generic machine, that you can bring every kind of data and give the true positive and the false positive to the machine. It will work through the night and give you in the morning the examples. We took it to the crime prevention area, and we found out that, matter of fact, we were pretty good in the post investigation. We were 100% correct. We didn't know exactly when and where the crimes would take, but regarding the people that will do the crimes, all of the people that committed the crimes were in our blacklist, and the blacklist wasn't all Israel. It was pretty small, and we had 100% of the people were there. So we were very happy. We started running it for a few months. But then we realized that we do find them in post investigation, but how many crimes did we succeed to prevent? The number was almost zero. It was less than 1%. And then we started analyzing why is that? The technology it works every time there was specific crime. It's not, I just open a parenthesis. It's not for any kind of crime. It's not such a specific kind of crime. And then we started to analyze, and we understand maybe we have the minority report conflict. I don't know if you're familiar with that movie. So we did know which people will make the crimes, but actually you can't stop the person before he commits the crime. So this knowledge doesn't really help the police or the IDF in any kind. So then we understand this, where it hit me that we need the data science revolution 2.0, I call it. It's not about the technology, it's about the people. I don't know if you're familiar with the singularity point, I call it technological singularity. It's being phrased at the point where the machines will not only outpass the human capability, but will actually rule the world, because the machines will be capable of creating machines that are better than us, and this is where we maybe will stop being humans, or I don't know exactly where. And the question is, are we ready for that? And from my experience, the project that we did, organizations that I visit were not ready for that, because all the articles and the organizations that I visit show me this graph more or less. The thing that in each lecture there is at least one logarithmic graph. So this is already the second one in this presentation, so we are good. And they are showing that the human performance evolves slowly, linearly, doesn't surprise anyone. And the computer performance obviously is exponential, and so it doesn't matter exactly if we are here, or there. In different areas, the computer performance is much better than the human. Some are less. So more or less, we're coming close to that point. And what bothers me is that people are still comparing the computer performance to the human performance. Still realizing that what we really need to do is how to put together the human and the machines so the performance will change. And it's not a competition, because we're going to lose in that competition either way. 20 years, 40 years, we're going to lose. But we have to change the way we think and use the computers in order to make the change. So the data scientist is considered the 21st century unicorn. And it's true that there's a very big shortage of computer scientists in the world, in Israel, in every country. But I will suggest that if you want to make change and use really the AI in the organization, not theoretically, but in the practice, the key person in your organization is not the data scientists. You have data scientists saying that. It's the data analyst. The data science becomes more and more common. 5 years ago, when we developed the first deep learning in our organization, it was we had really experts that build the neural networks that come from the brain area. But now it's already how much a common knowledge. You can just Google and download pretty good deep learning networks. But as I was saying, if you want to make the change with the data analyst, then it will remain in the presentations and in the theoretical or the post-investigations and not make the real change. So I will elaborate of what I think should be the data analyst new role. First, it's all about the data. The analyst has to know which data to bring to the table, because even the best machine can't really create features from all the data in the world. It's not possible. You can't download it. You can't have it. Even Google and Facebook are having very small samples of data, then they run their algorithms on. So data analyst should know which data to bring, then has to tag it. It's black work, because the machine, especially if you use supervised learning, meaning the machine learns from true, as I explained before, the true positive and the false positive. So you have to tag a lot of examples so the machine can learn. The deep learning, you understand that before, the deep learning versus the normal feature engineering. The big change is that when you do feature engineering, you tell the machine, you teach the machine how to make a decision. For example, what is a bird? A bird, if you have wings and you have feathers and two legs and it flies, it means it's a bird. That's how you teach the machine. That's how it's a human engineered features. How deep learning features work, you just give the machine many examples of birds, and then it learns what is a bird. That's how our brain usually works. I teach my kid, I don't teach him this, that. I told him, he sees a few examples of something and he learns about the rest of it. Still, sometimes he mistakes. They call my laptop tablet, but you understand that that's the same area. It's not food or something like that. So you have to bring the data, you have to tag the data, and we are pretty good at this phase, at least in our organizations that I visited. And people understand that it's worth investing because it takes time and it's hard work, but they are doing it in order to teach the machines. Second role is the data scientist has to bring his experience and leverage it to the machine, not saying the exact features. Like a crime, a person who make a crime has to be male between 20 to 40 years old, etc. Not to bring the specific features, but he has to bring his experience from that area. He has to know to work and to analyze the data-driven results, meaning the machine finds patterns that you didn't think of, but you have to then confront with them and say if they are true or not, and examine those results. We're pretty good, not as in the data, but we are also we have the capability and the understanding. That's the role of the data scientist. The second role is to really make sense and change the judgment and change the insights of the person. In this, I give us a 40% grade because still places I visit, they trust only what they understand, and even though they got from A to D by doing A to B and B to C and C to D, and each phase was statistic, and we also measured it, and we saw that each stage was talking about one example that I can't elaborate on, but you can understand. Each phase was was between 80 to 90% correct, which is pretty good. But if you make all the sums, then the result in the end from A to D is 50%. But because they understood how they got from A to D, they didn't have a problem to get that results. And if the machine just told them this is D, they wouldn't take that result because it told me it's human lives involved. And I was saying exactly that human lives involved. So how can you not trust the machine and trust your intuition? Because I can examine and give a score to each intuition that you have and tell you exactly if you are wrong or right. So this is why I call it in math we trust. We have to the analyst has to start believing in those statistics. We are doing some phase that we call the how to get to the math we trust. We do work on interpretable machines that will help explain the person why the machine got to that conclusion. I think this phase has to be now because in order to make the people trust the machines, but sooner or later this phase should not exist anymore. And the analysts have to understand the price that they're paying right now and will pay in the future if they won't trust the machines. The last phase is that after we change what we understand, the insights and the judgment, is that really we have to change our action. Instead of being consequential, we can start being influencing. And the set of action that we do today might be very different if we know in advance things that the machine can predict. I will return to the example of the crime prevention. Instead of coming to arrest the people that did not make the crime yet, but if what we want is to prevent the crime, then we can change the way we think and use the AI to prevent the crime by doing, for example, if I know that the person is in the course of being a terrorist or crime doing, we can start influencing by introducing people that we know have a good influence on him. We can offer him a scholarship at the university. We can give them a permit to work. Works in different countries. We can influence the contents that he sees instead of seeing Islamic or things that are very negative. We can start putting good positive thoughts in his course of actions in certain medias. And if you start thinking about that, that's how we really will prevent the crimes. And then you can also trust the numbers because it's not human lives involved. This is the only way that I see that we can use the AI to change the future and the course of action. So thank you very much.
Go ahead, yeah.
Okay, fascinating. Just three brief points before our last speaker. Thank you. So I want to jump in on the differences between computer performance and human performance, and of course we can't deny that computer performance is higher, is better. The question is by which standard, and then whether it's the outcome of only the effectiveness or the cost effectiveness, which also calculates the cost, again, in terms of ethical and legal cost that the system generates and the biases that includes in the system. The second point is, that's the kind of the trend of the day to delegate human decisions to computer decisions to algorithm. The algorithm, especially in the field of terrorism, might be non-reversible. And there is this question of reversibility. It's one thing to, to decide to arrest a person at the airport. It's a different thing to decide that the person is a terrorist, and then you face some difficult dilemmas. What to do? Some of them are non-reversible, and reversibility is also applicable in the sense of that there is a point in deep learning, machine learning, and deep learning that humans lose track on how to explain the outcome, and that's also something to be discussed in the Q&A. And the last point is the human discretion. There are certain decisions that either humans are not willing to delegate to computer. I always give the funny example of that if there is an algorithm that can choose for us the best spouse, we still want to choose, right? But also in the sense of that those type of decisions, because of the sensitivities of the decisions, even if we humans are willing to delegate, maybe they shouldn't. Our last speaker is Mr. Omri Timianker. Yeah, sorry for the wrong pronunciation.
I will pronounce it again.
Timianker, yes. So Omri is the founder and the president of the Cobwebs technologies in Israel. Previously, he was at the IDF Special Forces and the Israeli Secret Services. In the last decades, I think since 2005, Omri has been engaged in developing technological intelligence solutions, and the company that he has funded, Cobwebs, introduced a novel approach to the world of world intelligence. So we are looking forward to hearing from you, and the floor is yours.
Thank you. So thank you very much. It's very challenging now after the amazing speakers that we have over here. So I'm sure that they're going to have another nice show that will combine it. So my name is Omri. I'm 40 years old. I'm married with 3 children. So now we are knowing each other better. So that's good. I'm coming from the field, and it's very important to the story of technology, I think. As my colleague over here said, that the most important person today is the data analyst. I think so as well. The people, very important, but we need to engage to give them tools that will help them save times and will give them better intelligence. Usually I'm starting this presentation in the last 15 years in a story, so if someone heard it already, please don't tell anyone. And the story, I think, is really give us a very good sense of our challenges today. So 2 people are going in the jungle. They're just traveling over there, and suddenly they see a big lion staring at them. So they're staring at each other. Observation, intelligence. Okay, this is the start. Know your enemy, right? So one person turn around, run away very fast, and the second one, still staring at the lion, sit down and change his gears to a running gears, and then start to run away. So when he's bypassing his friend, his friend said, "Hey, what are you doing? Do you think that you're going to run faster than the lion?" And he told him like that, "No, faster than you," and keep on running. Okay. So I think the challenge that we have today, this is a short story, but it's really important because there are really small winnings today, small victories in every phase, in every vectors in our intelligence and operations. So Cobwebs is a global company. Just 1 minute about Cobwebs. Global company that we founded 4 years ago. We are specialized in the field of web intelligence. And I think that one of the most important thing of a company when you start to build a company is the focus about the domain that you are developing and not to go right and left and stay there. We have dozens of end users today, only after 4 years in many, many countries using our platform. And it's important to say it's a platform that gives a very good wide solution to the operation of web. Today in our field, in the field of law enforcement and the challenge that we have many vectors that we need to combine. We have the SIGINT, we have the cyber, we have the WebInt, we have the VISINT, and then we try to synergy between them. I'm going to talk about only the WebInt and the synergy that we have in AI. The platform that we have, we are trying really to develop it all the time with new modules and new technology in that field to give you a better intelligence picture, because at the end, we believe that when you sell something, it should be with operational success at the end. Okay? This is what guides us all the time. Simplicity of use. So we see Google as a very good vision to the UI of a system. Even though it's a complicated system, the use should be very, very easy. Okay? Google style. It should be enriched to everybody, from a sheriff office to give him the intelligence to a big organizations. And at the end of the day, it should bring operational success. And this is what we are talking about a lot. So we added many modules in this platform of target profiling, that it's a very important thing today, how to profile a person by his social media accounts, how to unify them, how to combine, how to understand a about the person only in 5 minutes, what usually takes a lot of time if it's manually. Live data, this is the monitoring phase. The AI capabilities that I will talk a little bit about the synergy. Avatars, influence today, if you want to get additional information, not only from the public, that over there, public information, you need to engage people to make more cyber-human operations. Dark web, that it's a very important source, but I think that operationally wise, intelligence-wise, we need to take the information from the dark web and try to match it to the real world. So a username, hashtag, something from groups over there, try to match them to people in the real social media, because everybody at the end are doing mistakes. And this is what we are looking for, right? Mistake of one person. When you put a name, phone number, email, something that we can take from the dark web and put it in the real world. And one very important, I'm very proud of that, this is also kind of unique mobile applications, like Telegram, like Snapchat, that you don't have web. It's not a social media, it's a 50% social media, but people using that. And if you can take this information, again, only what's public, and to do some analytics in order to get additional information from that, this is very, very important. And many, many of the social media and different applications today going, of course, to the mobile applications. AI, I will not put more. I'm not a scientist. I'm not a technology person. I'm from the operations. And what we try to take from the AI at the end is insights, especially from picture, OCR, object recognition, to teach them about things that are very important for us, like ISIS flag, like weapon, like knives, like some symbols that we would like to understand and get more information automatically. We are working with ICT about in the last 2 years with internships program that people in the second degree coming to our company, 3 months for 1 semester. So I think that we have over here one of our internship persons, and we are trying to teach the machine these kind of things with this amazing program of internship. So for me, in this synergy between AI, I'm talking about web intelligence. If you have a profile, Facebook profile with many, many pictures, just to try to understand what is the most important thing for me. If you have over here, there are people with bird, or OCR about jihad, or some flags in the pictures, or some weapon in the pictures, just give me an alert. Because then, as we said, the analyst will know what to do with it. This is the start. One question before, if it's okay, if I will ask you, are there any operational people over here from law enforcement? What is the combination of the crowd? Okay, and the other one coming to learn a little bit about this new technology, right? So I will try now to take everybody over here to a scenario, okay? Let's take all what we spoke about over here and try to put it in a real scenario, in a real case, and try to understand what we can take from that, from this information. And if you remember, if you are probably seen many movies, it's based on a true story. Okay, so it's based on a true stories, and I will stop over there. But I left 15% of fantasy, or things that will be, but not so far away, okay? 1 year, 2 years, I think that it can be integrated to a full solution, combine all this kind of technology. So let's start with monitoring geographic area. When I'm saying monitoring geographic area, I'm talking about only web intelligence. So we just put a polygon over there. That means that if someone will post there, will tweet there, will do something over there based on location, we will gather it. But because it's too wide, right, we'll get a lot of information. Let's take it targeted only on the hashtag Islamic State. Why? Because now this is my mission. I'm trying to bring leads. Okay, every start, we have many, many challenges, many missions. Now the start is just to bring leads based on Islamic State in Europe. That's it. So when we're doing this monitoring, and we add a lot of keyword alerts, dictionary, pictures, just give it to me. This is, by the way, the UI, so Google style and Google feel. This is how we see the platform. So when we will do that, we put a geographic fence just on Europe with the hashtag Islamic State, and we try to bring a lot of information, okay? See it over here, Islamic State, green, that means that it works. And now if I have a crime center, intelligence center, fusion center, it will start to gather the information over there and will give me an alert based on the things that I wanted to say. Up until now, it's still based on true story, okay? Now, I got an alert over there, and the alert will be this post that say that it's a sharing of Telegram channel. Now in the post, and why did I get the alert is because of this knife, okay? So now it's 15% fantasy, okay? We get a knife, we get an alert, but it's there. This is the machine learning that people are working on it, and it will be there when we'll teach how knife looks like. So from this geographic fence monitor, now I have a Telegram channel. So are you familiar with Telegram? Probably, right? It's a big channel today. But what's public over there when you have channels, it's like Facebook page or it's like Facebook group. So you can get some information from there if you're doing analytics. So we took this channel and analyzed it. When we analyze channel, first of all, we have a username over there, okay, because we have an account. We have all the history of how does it work, okay, the peaks of over there. We have only one publisher over there, but we have the sentiments, and this is based on NLP and sentiment analysis. So we are supporting 25 languages in this, and what is sentiments, bad or wrong or right, and this is again something that we need to teach the system as well, because let's say Jerusalem is a very place, can be very good in Israel when you say that, but it's over there it will be bad. Over here the sentiment is bad, okay? So it take all the posts over there, extract it to entities, and add sentiments to the entities. So I'm going to Paris, it's not so good over there, it will be negative sentiments, okay? So this is the analysis of the channel, all the posts that you have over there, all the entities that they talk about, the cities, countries will be in yellow over there. It's just on the map that you have a visualization what the topics on the countries that this channel is talking about. And all the topic analytics, so NLP, as we say. What is the word over there? Now I'm talking about targeted channel right now, right? We got it from a person that posted with a knife. So the profile, the analytics that we have over here is based on this channel of Telegram. From there, we took the username and analyzed and searched for the username. Because now from this channel, we have a username, and now we will search for the username. Maybe we can identify more information about that username. And this person over here, a little bit slow, okay. So we got results, and we already know this person because I get an alert. This person, you already had some investigation about him, okay? And again, this is all the information all the time saved, and we all the time check if we already saw him, because this is very important, right? But the person, and this is the person because we have the target on him and we understand who is he and what is the information that we already have. But the person over here just below him, I don't know him, so I will analyze them. Now what I'm doing over here, and this is now based on a true story that we had when we found in a demo, by the way, in a demo meeting, one of the biggest recruiters in Europe for ISIS. ISIS works, as you know, with many honey traps inside of Facebook and other accounts. When they put people, if they see in Facebook accounts that someone is more religion style, they will start to hunt him and start to be friends of him and try to take him more radicals. And we had a demo, and they gave us 2 people that they think going to recruit ISIS, 2 Facebook accounts. That was the mission, 2 Facebook accounts, very limited, 15 friends, 20 friends, some pictures with birds, with weapons and on. And we analyzed both of them accounts, and we try to find who is their mutual friend, okay? So what you see over here, this is a person that is a friend of this account and this account as well. They're not a friend of each other, but he's with them. And as you know, terror organization work with small units. They don't know each other, but someone is controlling them, right? So it's like a net. So now the most important person for us is this one because he's combining. He's a friend of them, and probably he's with a higher rank. So we would like to target and profile him to understand more, get more information. If I will go back for a short moment to the story that I had in the demo that we had, we found that a Facebook account that is a friend of both of them, no picture, no friends, block account. If you're not his friend, you can't see any information. In the system, for us, it's a challenge, but we know how to overcome it. And we reconstruct his account, and we got a 1,000 friends account with friends in every capital in Europe, friends, many, many friends, Albania, Kosovo, all this area, friends in Turkey, friends in Syria, friend in Yemen, friend in Iraq, okay? So it's like the whole silver way from recruiting, sending them to Turkey, and then to the camps in Iraq and Yemen. So only based on that, they bought the system, okay? That was good for us. But they had a lot of success from there. And this is only unveiling the connections between 2 identity, 3, 4 accounts. So now, I'm going to the fantasy again, because everything now is true, based on the true story. And let's try to understand who is this person. So, we have 2 people that we know already, and now we will try to make face recognition. I think face recognition will be very, very helpful for law intelligence in the field of web, when you can understand who is the person, like Shazam for people, but it will go to the actual information about this person. Because today you can't hide it. Someone will tag you. Someone will write about you, even if you don't have any social account. People are there, they are doing things, and you can't control anything. So let's try to do it. We'll upload this picture. And scan it. So in the field of next year, 1.5 years, again in the fantasy world, what we will be, it will take this face. If we already have a target, like blacklist of people with Interpol, with other sources, it will go to this storage and try to match this person. Do you know him? Do you know him? Do you know him? In order to make a match. And we'll go outside to the web, open web. So it will go to other sources and other data sources in order to understand who is he. But just from the picture, to give, okay, this is a male, this is his age, this is his emotion, this is what objects that he have. And when he will come and will bring more information, maybe we will have the WhatsApp account that he have, the Telegram account that he have, and some things from other sources. And this is very important, the cooperation between organization on the information of people. On people, it will be on the top 10 of the FBI most wanted terrorists, okay? So this is the fantasy. It's not there yet. We implement over there, so don't think this is a real terrorist. But this is the synergy as we see it. Using all those sources of AI, all the capabilities of technology, to synergize them in the same vector. So the R&D of the product, because again, we need to bring platform that people will use. People will use it like they use Google. People will use it like they use the social media. This is our challenge as a company that is a product company. While adding these sources as well, we can try to start from something, just lead generation, make more investigation, and then at the end to bring some operational success. If you have any more questions, I'm here. Thank you very much to be in this time, and hope to see you next year as well over here.
Okay, thank you so much. We have about 1 hour and a half for questions. So the way we will go is if you have a question, please briefly introduce yourself. And then at the beginning, I will pick 1 question at a time, and then we'll see how much time left and whether I will pick some questions in group. So who goes first? Please.
I have a stupid question.
But please introduce yourself before the stupid question.
Hey, Christian from the University of Copenhagen, Denmark. I'm no expert on the technical side of this. Nonetheless, I was at a very convincing presentation last year where they went through this object recognition technologies, the latest ability to face recognize, to read objects, pictures, and so on. And what they quite convincingly showed is that by altering very few pixels in a given picture, the AI will be unable to actually detect it. And I was wondering, going through all your presentations, if that is indeed the case, first of all, how much you would have to alter to cheat the AI, and if you've seen any altered behavior with the people who we are monitoring in terms of that. It would be quite a small task for a potential terrorist to alter a few pixels in the ISIS flag before posting it and thereby go undetected by these technologies.
Is this question to a specific speaker or like an open one?
I think a lot of the speakers would be able to say something interesting.
Who wants to be the first comment?
I've actually seen an example of that on YouTube. So ISIS videos, basically all they did was just add snowflakes falling on the ground, and then it's not detectable. So I've definitely seen cases of it. I'm not an expert in image detection, but I do believe that this is something that we need to overcome. Maybe Omri, you have something to say about it?
Yeah, just to say, this is part of the challenge that we have. So all the time something will happen, and then if you have a strong R&D and you have a lot of experience, this is a thing that we will try to overcome them. But it's only the object recognition from a YouTube movie or something like this. We can try to understand where it was published, and then we have location, and then we can do other analytics on that. But this is part of the challenge that every time things will happen.
Comment also about that. It actually depends. It's don't believe any presentation you see, because no, probably I believe that the example is 100% true, but it depends what was in every algorithm. There is a soft spot, so it depends what was a soft spot of the algorithm that he addresses. For example, for facial recognition, there are some algorithms that focus on feature extraction from the eyes. So you can show if you cover the eyes or put sunglasses, that algorithm won't work. Other algorithms look at the distances between the eyes, the nose, and so if you know exactly how the algorithm works, you can probably cheat the algorithm. The thing is, if you have a good, robust algorithm, it's hard to be cheatable because it consists of many layers. So even if you cover some layers, others will help you. And besides, generally, it's like every thief and this game. Like for every algorithm, there's a soft spot. Then if you find it, like a cyber, you fight it. Then we overcome it. Then you have another challenge. It's always this game.
I'll just add to that. For example, practically today, as Omri said, David said, we have the ability, some of the algorithms have the ability to detect, especially when we're talking about face recognition, to detect the same person, even if he changed some of the features from his face, because terrorists today do not go to the airport with the same face. They're trying to cover it, whether it's a wig, beard, sunglasses, or something else. And today you have some algorithms that still detect the same person, even if he changed some of the features. So, as you said, maybe the example that you showed was 100% right, but it depends on the algorithm. Today, it's not a clear cut. You do have the ability to detect object faces, even if some changes have been made.
Okay, thank you. Please.
Hi, my name is Fulcher Valentine. I'm a master's student at IDC studying counterterrorism and homeland security. I wanted to ask a question to Dr. Woodard and to Yaniv from the Mishnah. It sounds like you have a problem and you have a solution. You have too much data, more than you know what to do with, and you have a program that can help analyze that. Are there obstacles to cooperation, or are you finding that you're able to work together well and utilize this technology?
I think on a general level, there are obstacles to collaboration, not necessarily with Israel, but with law enforcement in general, because there are many, many limitations in terms of security, in terms of access to classified data. Like I said in my presentation, in order to train the system effectively, we need lots and lots of data. A lot of those data sets aren't releasable to private companies. So there are lots of security barriers, I think, that challenge us. Another thing is just kind of administrative things. When a private company wants to enter a law enforcement agency, dealing with a law enforcement agency, sometimes it's a very long time before you can get something deployed. So there are lots of challenges in terms of, LEA saying we want this deployed absolutely next week, and then we won't have it deployed for another year because there are lots of kind of barriers in between. But they're mostly things related to that. I wouldn't say it's necessarily, technical or I think there's a lot of will, but there are barriers that we can't really get around sometimes. What do you say, Yaniv?
I agree. First of all, we do cooperate. Even Jennifer mentioned that we are part of the same project today. There are many limitations. most of them are not technological limitation, whether it's administrative or legal constraints, but I do see a change. I mean, for example, like 10 years ago, many law enforcement agencies or other intelligence agencies would rather to develop the technologies by themselves. Today, we do understand that the private sector has advantage, okay? It has sometimes more resources, more experience than we do approach to the private sector in order to get a solution much more than 10 years ago, for example.
More questions? Yes, please.
Hi, my name is Anna. I'm an IT security consultant. One of the things that you mentioned is you have to deal with the issue of anonymity. Sorry. So last year, I don't know if you're familiar with the DEF CON conference. There was a talk where a journalist and a data scientist they were able to get a hold of click streams from 3 million German citizens, and just by looking at where they were, what sites people were visiting, they were able to pinpoint who that person was. So for instance, they were able to get information on a judge that was looking at hardcore porn, and they were able to just pinpoint exactly who that person was, even if the data they were having was anonymous. So isn't that something that would be helpful for you as well, to get a hold of that kind of information from Google or other marketing companies or something like that, and just try to pinpoint all those, I don't know, terrorists that are hiding behind Tor sites and all that stuff? So how would you approach that kind of situation? So
Who the question is addressed?
It's a big one.
Yeah.
And they would say we can't really reveal all our techniques, but we do use many types of identification techniques. One of them is trying to identify the fingerprints. There are many ways to get fingerprints of the user, whether it's by the browser, by his activity, his way of activity to identify that. There are some techniques, but it's a constant struggle because they learn how to disguise. Once, for example, this kind of example is known, they learn to disguise themselves in other ways. Okay, there are many ways to change your activity pattern, even if it's automatically. Okay, there's a way to disguise your browser fingerprints in many techniques. So it's a constant struggle. It's not a clear cut.
More questions? Yes, please.
She'd come without the uniform. Well, yes, it is a challenge. One of the way to try to overcome that is the AI. Okay, the AI today has the ability. If you train your machine well enough, it has a better capability to identify the false traces with the true traces that can link to the perpetrator or the criminals or whatever it is, but I can't say it's 100%, okay? We're always being fooled by some of the actors. We are trying to be smarter than them. AI comes to our help in this matter.
Yes, please.
Counter-Terrorism master's student here in the IBC. I have a question, again, general one, not specific. So we are using advanced technologies, and we want to use it to our advantage. But I want to assume that also the other side, the terrorists or the other countries, do the same. Are you monitoring or spying on them to see what kind of use they are doing against us? And if yes, what have you find out?
I'll leave it to you.
I I could speak to the fact that, like David was saying, the role of the data analyst is super important, and that actually, in the case of LEAs that we're working with, what they are mostly looking at are the behaviors of changing, for instance, changing ways of speaking, changing channels, those types of things we're kind of building into the systems, understanding, for instance, that a message can begin on Instagram, and then it goes to Telegram, and then it goes to a just pasted account, and these are the way that terrorists are interacting with each other. But it's more of a behavioral thing, and learning about how they are switching their behaviors. But I mean, it's kind of a joint role of the data analysts on the commercial side and the LEAs kind of working together, because obviously we're not monitoring data all day long. It's the LEAs who are doing it. So I think police are really key in kind of understanding these types of trends, and they actually come to us and they tell us, this is what we're seeing. So we build those things into our models after we speak with law enforcement. But it's like they were saying, it's a cat and mouse game, because these things are, it's dynamic, it's constantly evolving every day. So if they know that you're looking at them here, they're gonna go somewhere else, and they're gonna open up a new channel, then they'll shut down another channel. It's really hard. I don't know that.
I can say that they're trying. Okay, it depends on the actor. Okay, if it's a big actor or a small actor, I can say, for example, that in the organized crime, the bigger organization have departments of developers, hackers, really, that we would like to even to hire some of them. So they do a lot of effort in this direction. It depends on the actor. But yes, they're trying to get them in. As I said at the beginning, military grade weapons goes today to even to a script kiddie. Okay, so better, even more organized with more resources, is trying to get higher weapons, higher means and technologies.
Tell you who's doing the best surveillance these days, and this is the big companies, Facebook, Google, etc. They're the best surveillance agencies.
Yes, please.
I graduated here at IDC in Counter-Terrorism like 2 years ago. I have two questions actually. One of them is for both Major Azani and for Mr. Timianker, which is about Telegram, more kind of a technical question. So as far as I know, Telegram was created in Russia. All of you know much better than I do, but it was created in Russia exactly for the purpose of escaping the Russian federal government, and that the only way to actually hack it to this day, I might be wrong, is to actually mirror the screen of the subject himself. So your plan is pretty much to implant a virus in every cell phone of every subject that pops up on your systems. Because if that's the case, that sounds quite a lot of work, kind of an impressive amount of work. And the second one, which is only for Mr. Timianker actually, is about facial recognition. And what if they go hidden, like Bin Laden style, but they never go public, or if they even use someone to be their public face, and they hide behind kind of a mirror.
So I'll start because I have two answers. Okay? And I don't have a uniform. So, thank you for the questions. Regarding Telegram, what I showed over here, it's open channels. So open channels, it's Telegram today, they have part of the things of Telegram, it's like public social media. So when you have channels over there, and you are there like a group, so you can collect information. And what's important for us as let's say intelligence organization is to understand who is the most influenced person over there. So just take example as Telegrass, okay? This is a Telegram channel that help people to get drugs, right? So you don't want to understand who is buying, you want to understand who is selling. So this is, if you analyze it and you see the communication, the people that get more likes, more shares, or more, let's say, not the contents of the messages over there, the private, because this is hacking, and we are not hacking. We are doing only what's public, what's available over there to get. And hacking, this is the next step. So as I said, there are vectors. So cyber operations, malware, this is the end game. So it's like to shoot in the gun, okay? And before that, we gather intelligence. So when you're doing field operation, and we just need to understand where the person is. Say, okay, this is the house. This is okay. This is us. But now the SWAT will come and try to kill him or arrest him. This is like more the Trojan horse operations. So it's just there is separation between these fields. But again, it's a synergy. It's an ecosystem that we need, and this is part of the challenge today to try to make a fusion for it. And if you don't need to shoot, don't shoot. If you can arrest without it. But if you need to shoot, so shoot very, very targeted oriented on this specific target as a mobile phone. This is one from Telegram to the cyber, what you said. The second, regarding face, there is not one solution that someone say, okay, we click on a button, now everything is happening. But Bin Laden had a driver, and had a wife, and had other people that probably we can follow them in order to catch him. So in the operational, let's say, doctrine, we learn all the time. Usually the target is not really the target because it's very difficult because they live in caves, okay? But there are some people that will, at the end, they need to eat, they need to sleep, they need to see their family, friends. So something will happen. And this is what we are trying to collect, okay?
Specifically about Telegram, I cannot, I'm limited with what I can say because of some operational issues in the current time. All I can say is that your basic assumption is wrong. Even in the technological vector, this is not the only way to address the issue.
More comments? Yes, please.
I'm in law enforcement. I'm the mathematician and the electronic engineer. So I'm at the ground thing of things. Here's my question. In the last 3 years, what we found is that machines over time obviously are influenced by mathematicians, whether we want it or not, okay? Have you found that your machines are becoming more and more biased over time and very, very difficult to budge from that bias curve that goes up? It's both for Dr. Woodard and David in particular because we're in the same field.
I think it's a challenge in getting back to the role of the data analyst. We're talking about tagging. David was talking about tagging, what we call annotation. It's challenging because, for instance, who decides what's a terrorist-related content? I mean, maybe that's easier, but who decides what hate speech is? Hate speech against Jews or Muslims, or who decides it? A human being. So what we try to do is to not just have one person annotate all of the data. We have lots of people annotating data, lots of people with different ideologies, and obviously trying to make sure these people are not imposing their ideologies on the data sets, but it's pretty impossible to get around. So I think it's a challenge that's ongoing.
First, of course, it's a big challenge, still not solved, but there are a few techniques that help us and few technologies that are pretty much new to help that help us to defeat this challenge in the names like reinforcement learning and active learning, etc. Meant to do that. One of the problems beside the bias is that what happens to the algorithm or to the machine over time. Because when we're in the lab, we mathematicians, we show me what the result you want to have, and I will work the numbers, so it will work, right? We know that. So, but the problem is, once it goes out from the lab, it maybe works good, but in time, it's really degrades in time, right? So, in this challenge, what we are doing right now is we have I show the pipeline, but it has another stage that there is another AI that sits in the end and sees what the customer or the data analyst saw, worked, tagged, what helped him and what not, and reinforce and does a reinforcement learning, brings this data back, and the machine always changes with time. So this is for what you do with the machine in the degrading with time. What you also mentioned, the bias, it's a true problem. Because if it's supervised learning, you always will show the example that you taught the machine, so you won't find black horses, that will find only the things that you taught the machine. So what we're doing in that, we're starting, it's a pretty new challenge for us too. First, we're using some of the algorithm is built to be unsupervised learning algorithm, and not only with examples to show things that we didn't teach the machine to find. This is one answer. The second answer is we sometimes plant and different answers that got a very different score, but we want to see how the person react to that, and if in time we see that some of the answers from another area, if we look at the problem as a matrix of n dimensions, so we bring answers from different dimensions and see how he reacts to that. And if you see it's a good lead, so we sometimes find new leads like that. But this is a pretty new, it's a big challenge in the academy too, so yeah, pretty fascinating.
I want to have a follow-up on the biases issues here, and to bring in, again, ethics and law. So I have a story and then a question. So the story is, I think it was last October, in the morning, police officers knocked the door of a Palestinian who posted a post on Facebook. The photo showed him close to a track, and he wrote something which the algorithm interpreted, it was in Arabic, as heard them. He posted good morning, and the track was part of, I don't know, part of the neighborhood or something. But the algorithm understood it differently. He was a Palestinian, there was a track, and it was understood as heard them, and he was arrested. Now, mistakes happen. Human makes mistake too. But in law, you have to have two conditions which are in the algorithm realm do not always exist. One is you have to have probable cause, or at least individual suspicion. And second, which is more important, it must be nearly turned into an individual, to a person. So I'll give you two scenarios. Scenario number one, if I am at the airport and I'm profiled and questioned, and there is something suspicious in my behavior, I might be singled out, but then there is an individual kind of probable cause and individual suspicion. Scenario number two is that there is an algorithm, I'm sure you have heard, that can, by facial recognition, can identify in the accuracy of 82% whether the person has a tendency to be violent. Now imagine that we are now not 82%, 98%. Scenario number two, even though it's more accurate and more effective, will be from the legal and ethical point of view more problematic, because there is nothing individual there. It's based on statistical evidence. And statistical evidence are always problematic when it comes to law and ethics. So I really kind of want to push you maybe to say something about the ethical challenges that you have in your work, and what are the best ways available to overcome them. So that's an open question too.
So I can answer from the developing point of view. So because especially when you work globally, each country has different regulation against privacy rules and privacy and regulation. And when we try to develop a new feature or something like this, it's not a decision making, it's a recommendation. So I think this is part of the mechanism that we did. It will be only recommendation. At the end, the analysts have more data. Maybe this is a person that they have already public record or criminal record or something, so they can do match. But it will be just a recommendation or alert. Hey, this picture, this post, there's something there. Please check it. And now a human that understands Arabic, we need to read it and then to say, hey, it's good morning. It's not goodbye. Okay. So I think this is the synergy. It's not only the machine. At the end, human, the analyst should see and verify, then he will pass it to the higher ranks in order to get decisions.
Okay, so there's always human discretion.
I think so, yes.
More comment? Okay.
Yeah, I think, yeah. I think if you will always be a person in the loop, and then it will be to be a bottleneck. And then you're right. When it's human life, you have to make these decisions because you want to be in a country that you want to live in. So you have to make this adjustment where you're saying I can trust the machine and not put the man in the loop, because it's obviously be bottleneck. And when you decide you want a person, and when you even decide you're saying you have the technology, but you don't want to use it because you respect the privacy of the people, and the country is more important than the well-being is more important of the civil rights than to stop one terror attack or another. I will just address something you said in the beginning, which is a true challenge of how you even identify a person before he acts a crime. Just in the theoretical area, if you want to predict these things, that you usually use anomaly detection, and then you get a better results and less false positive, and arrest people that are angry or anxious or excited from some reason. Because if you learn this kind of person, then you put an algorithm that suits to that person, then it's easier for you to find an anomaly to this kind of person and not a global anomaly. So that's kind of also technologies that are being out to help in this problem.
And getting back to the cultural differences or the national security differences, there are vast differences between countries, even within Europe. The project that Yaniv and I are working on, for instance, we're developing an end-to-end encryption, complete anonymization system, because one of the law enforcement agencies doesn't have access to these types of, isn't allowed to look at people's profiles, isn't allowed to conduct an investigation. So what they need to do is see the anomaly, receive an alert, and then at the end of the process, reveal who that particular suspect might be, because their national regulations don't allow them to investigate people unless they have probable cause or they have a court order. So it varies immensely across different national security regulations. And I think there's also in some countries now a stigma attached to the kind of work that we do. In the case of the US, there was a pretty famous case that happened, I think, 2 years ago, where one of a system that's similar to ours was tagging Black Lives Matters content as terrorist-related content or extremist content. Why? Because someone taught the algorithm that is what it is. So that's kind of getting back to the whole, are we biasing machines? We just have to keep an eye on it. We have to use, other methods for making sure we're not kind of instilling our own beliefs in the systems.
Thank you. Yes, please.
I guess I want to relate to that. I think eventually it's a matter of prioritizing. Today, what Omri said today, it's still the easy way to decide that eventually you'll have a human factor having the last decision. But soon, as you said, the efficiency of the machine is going to be higher. And then the question will be, are you going to allow the human factor to be a bottleneck when you can save lives? For example, if you let the machine decide where it has 98% of success, which must be even better than the decision of a human factor, would you still let the human factor be the bottleneck when it comes to prevent to save lives? So it's not a clear cut, and definitely not going to be a clear cut in a few years from now, very quickly.
Yeah, that's one of the biggest challenges in this field. Yes, please.
We talked about radicalization and extremism, and possibly you have one solution to counter it. Question is the definition of radicalization and extremism. Who defines it? And is there a need to change your keywords if it's a political one who radicalize and a religious one? And the second one is there a need to have an international law against your system?
Good question.
No, to the first question with regards to kind of how these systems work with natural language processing, for instance, I mean, there's always going to be a data set that we're using that's teaching the machine what is radicalization or what is radical content or what is terrorist-related content. So what we try to use are real cases. And like I said before, it's really hard to get those real cases. It's hard to say, okay, here's 1 million messages of people who have committed terrorist attacks. But if you have that, you can pretty much say, okay, this is radical because this person actually carried out an attack. It gets a little iffy when you don't have a lot of that data. So you either have to create the data, emulate data, try to work with law enforcement to get additional data. But I think that there's less of a chance of bias when you have these kind of real cases to feed into the system. Should there be a national regulation against our system? International, wow. I can say that at least, I don't know, probably Omri is experiencing the same things. I mean, it's kind of being regulated by the fact that national governments are putting pressure on social media companies. So then social media companies are limiting the access they give to companies like us. So it's kind of almost kind of self-regulating right now due to, the Cambridge Analytica scandal, the fact that lots of people are being kind of surveilled online. But I mean, I would hope not, because the systems that we're building are in the best interest, or we believe them to be in the best interest of national security or international security. So.
I may add to that a little bit. First of all, it will be a disaster for many companies and for law enforcement as well if there will not be companies that develop solutions independently, because this is independent solutions. And part of the challenge that we all have today is to collect the information from the social media. They are shutting down their API. You can collect the information. Even yourself as an analyst, a manual analyst, you need to do a lot of work in order to get some information. So I think it's the best interest to do, not against us, but to help those kinds of companies to keep the solution, as long as it's fitted with the law enforcement challenges and not commercial challenges or political challenges. Because I think this is what with Cambridge Analytics was, that at the end this is to influence people to vote to other people, and they bought this information from Facebook. So that's commercial level, they bought it and then they use it. For the challenges of law enforcement, it's different, and if you can collect independently without being need favor from your connection, personal connections in Facebook, Google, or the other social media, if you do it by yourself, target-oriented or mission-oriented, I think that would be the win-win for everybody.
Maybe just one more point. I'm a lawyer, and lawyers usually tend to think that everything should be regulated. So for lawyers, the question is not should there be international law, but what should international law be? And that's a difficult question, because you have to come up with some goals that you want to achieve by using those emerging technologies, and also by standards in which to measure them and to evaluate them, and that's highly disputed. And then you have to make the accommodation for each of those goals and standards in the very specific context in which you regulate it, whether it's terrorism, migration, and so on. And that's almost impossible, because lawyers also need to understand exactly why they are regulated, and they have to rely on experts who have biases, etc. So that's a huge challenge from a legal point of view that is discussed in different forums nowadays. But the question whether it will be regulated is a big one.
I will add just one thing. I think most of the companies take the information that it's public over there. So someone posted something, it's over there. So he really did an action and posted, so he knows that it's public over there. And the algorithm that my colleague over here, it's on the contents of the posts or the entities that people posted. And what we have is the information that we gather from the public and open source social media and open web and everything. So the international law, if you something like this, it's more something that's more hacking wise. And I think this is more because, again, to shoot, to kill, this is one thing, and just to observe is something else.
Well, also, as a lawyer, let us not forget GDPR,
Yeah.
which doesn't only apply to Europe, it applies to data that's being generated outside of Europe, or data that is being processed within Europe. So GDPR actually is regulating us even further, because many of the tools that you'll probably find that have been out there for years for doing like marketing intelligence, they're probably not very GDPR compliant at all, because they are handling data in ways that the GDPR is already restricted.
More question, yes, sir.
Yeah, my name is Daniel Wenzel. I developed a computer game that simulates real life. And then the question here, we're talking about good guys and bad guys. And it's a race. Who has better AI? The good guys and bad guys, both of them can develop AI. And I assume that the good guys have more resources. Otherwise, the bad guys will win anyway, and that will be the end of it. So if the good guys have better resources, I'm wondering if, as part of this, the good guys develop a computer that has a neural network topology, which means that in hardware, you implement the neural network, which would be difficult to do and very costly, but it would give a clear advantage to the good guys using AI. Is there such a thing, or I'm just curious if there's such a development of a computer that not AI neural network that is software implemented, but hardware topology that is in the hardware.
Yes, I'm not familiar with things that are self-engineered. Of course, there are the competition now about this. It's called GPUs, and then the performance of those GPUs is not only which kind of graphical processor and how many CPUs and GPUs you have, but is also how the communication between the different cards and how the architecture of the whole complex. Because sometimes you get to that your bottleneck is not a processing unit, but it's the I/O that between the different chips. So now there are developments, but there are the big companies develop their own chips. Like Google has the TPU, right? So the GPU, and the IBM has remember they have different. They have also their own GPU computer. I'm not familiar in our country at least that we develop our own
neural network based
hardware, because it's usually not so cost effectiveness, and the big companies, it's a race that the big companies always win. So we cooperate with the big companies. It's cheaper and faster.
More questions? Yes. Yeah, it's not a question, just to add a comment on the gentleman's question. I think it's a fair question, but it's very complex, because yesterday was mentioning cloud computing, and everyone can reach cloud computing. Here you have HPC, soon you're going to have quantum computing. So I think the bad guys, unfortunately, will be able to use these resources as well.
Yes, please.
I have a question for Dr. Woodard. At the beginning of your presentation, you showed a Mark Zuckerberg quote and said it was false that 99% of terrorist activity is taken down. What percentage do you think it is?
It's hard to say. I mean, that's my own personal opinion, because I think it's impossible. We deal with law enforcement on a daily basis, and they're telling us that this is a problem. If they were getting 99% of the content, law enforcement wouldn't have a problem with this type of content. So it's kind of the logical conclusion.
Do you think it's even half of the time?
I wouldn't even say. They recently opened up an office in Barcelona that is specifically to manually monitor content on Facebook. That means the AI is not working, I think. Why would you need 250 people of all sorts of different, backgrounds and language capabilities if you have an AI that's going to do that 99% of the time? And in the other half of his quote was, or on another day during the congressional hearings, he basically said, in 10 years we'll be able to do this. So there's a contradiction there. I think maybe it's kind of a speculation that's not a very nice one to make, but I think maybe there are some revenue implications of taking down some of this content. I know that's been the case with YouTube. Not blaming YouTube, but ISIS videos generate revenue. They generate lots of views, that generates lots of page views, lots of ads are shown. So maybe there's also a business reason why they can't implement these AI techniques. I mean, I'm talking about AI, Omri's talking about AI, for small companies. Facebook has billions of euros to invest in this type of content. On the, maybe the being the devil's advocate, maybe that's not what they have been investing in all of these years, and now they're realizing that they need to do it. But I think they could definitely find the capability. They're in Silicon Valley. There's tons of talent, and I don't know that.
Do you know what methods, like Facebook has a counter-terrorism department, do you know what methods they do employ, if not AI, to
I think
monitor?
I think I mean, I don't know about counterterrorism specifically, but they have manual monitoring happening all the time. So they have people who are subject matter experts, people that are experts in the language. They had a massive scandal with Myanmar. AI needs to play a role in that. I don't know why they've been kind of slow to implement it. Maybe they could actually work with outside companies who are already doing this to get a leg up, but I mean, it's a huge challenge. You can't fault them really. No one has this massive big data problem like the way they do. I mean, it's literally billions of messages in multiple languages every day. So.
Thank you. This side, questions on this side? No. Yes.
Yes, my name is Alex Ratzener. I used to work for the international central banks in security of payment systems and that era. But my question is a different one. The history, each one of us, good guys and bad guys, now have a history all our lives, which is basically somewhere in social media and networks. In the work that is being done, so there's a time before a bad guy becomes a bad guy where he leaves a lot of traces clearly on social networks and on the web. How important is that period in terms of some of the work that you're doing, this very historical data of bad guys before they became bad guys, basically?
Sure.
Is interesting. You address this question to who?
Well, Omri seems to be one of the obvious ones who's looking.
You mean for the development of the profile?
For finding
the suspicious.
For anything that you're trying to do, the time where he didn't know that he needed to be more careful in the use of what they were doing.
Yeah. So I'm not the right guy, but try to answer because we give a tool that at the end someone will use it in different challenges. It can be terror, it can be a drug, it can be anything. And at the end of the day, the history is very important because you can get a lot of information and intelligence from the history, but when he became a bad guy, I don't think that we have the capability to do it. I don't know if anyone has this capability to do it. You need to take many bad guys and to try to take all the history of the web, social media, and the web, and open web, and then try to find some pattern or some when it changed. And we are dealing with mostly with how to unveiling connections and to collect the people and to give alerts. So we are today more in preventing and less of understand where will be the change because he's already probably in jail.
So history is not that history
it's very important. It's very important, but more for intelligence. Right? Let's say if he did some like to someone, that communication, maybe this person is more important, or if some communication. So it's more based on investigation, from my point of view, more investigation-wise, less understanding when was the time.
I'll say also two things. First, the reality is much more gray than good or bad, unfortunately. And second, as I mentioned in my lecture, I will look to ask a general question. So the general answer is all data is relevant. Now, how relevant it depends which exactly you say bad guy. So which exact area or type of crime or country or more parameters you are asking this question, and the answer is I want all the data. I don't know what the result is, and I don't care because we will feed the machine, and in the end I can tell you if the machine found some features that were important in the history of the person, yes or no. But I can't know in advance. It's not also general for the same crime. Different people might use history, some not use history. So it really depends. Let's say bring all the data.
think it's relevant in the case of radicalization. So I talked earlier about a kind of experimental project we're doing with ICT based on that sort of thing. So here's a case of a guy that somewhere along the line got radicalized. Here's all of his Twitter data. When did he actually flip? But like David was saying, you need a lot of, actually Omri was saying you need a lot of bad guys to do that in order to implement a model that would actually be useful. But it's interesting in order to kind of understand when someone went from being normal to actually crossing over to the other side. I don't know if I'm citing the wrong case, but I think Boaz talked about a case, maybe it was the terrorist in Nice who apparently became radicalized in 1 week's time or online or something like that. That would be a use case for using that sort of historical data to understand how it happened.
I want to bring one more point. So we have discussed AI mainly, and I want to ask whether you have some insights to share, if you can share, on blockchain technologies and the way it is used by group to either spread terrorism or to combat terrorism. Is there anything to be said on blockchain technologies as well? Or you haven't done much research on it? No. So we have to have
the right
next.
panel. The right panel.
Yeah, next year we organize another panel. More questions. I'll collect 3 last questions in a row. So how many we have? We have more than 3. So we'll collect them all, and then I will open it for the discussion. So you can. No, you wanted to ask?
I can do it.
Okay. Yes.
Thank you very much to the panel. It's been really informative. My name is Lydia Khalil. I'm a research fellow at the Lowy Institute. I focus on international terrorism. But I'm also an advisor for the Boston Police Department adjunctly. And previous to that, I worked very closely with them as an advisor on their intelligence and counterterrorism division. So a lot of what you said in the panel in terms of working with law enforcement, I'm getting memories back from from that time. We had a lot of private companies come to us with predictive policing promises and different ways to use it. Granted, this was probably 2-3 years ago, so I think there have been many leaps since then. I guess I just offer a quick comment and question with that in terms of gathering data and the limitations that law enforcement can have. Sometimes I feel like the limitation is that the law enforcement agencies, particularly if they don't have a lot of capability, don't know what kind of data to give. So that's just something, just a quick comment to put out there. But my question is more on focusing on Google. A lot of the attention has been on the social networking companies like Facebook and others, probably because a lot of the law enforcement agencies and companies that are represented on the panel can access that public information that's out there. But I was wondering if you could talk about companies like Google who have massive amounts of data and information on us. And granted, that's probably private for them and they're not sharing it with other public companies. But if you could just talk about what that implication is. Do you have access to that type of information? It's being used privately for their own commercial benefit, but can that information that companies like Google have, for example, be applied to the work that you're doing for machine learning and artificial intelligence? Sorry, that was very long.
Thank you. Yes. More questions? Yes, please.
My name is Shai Fine. I'm heading the Data Science Institute here in IBC, and I just recently joined for many years in the industry. I served as a chief data scientist in IBM and Intel, a company like that, and the main, not the main, but one of the challenges that we were facing all the time is to generate explanation for the great detection and prediction, because you blend deep learning and all kinds of acronym, okay, and you end up with a great score, and now you need to provide a humanly readable explanation. I wonder if this is a challenge to you guys as well, and how do you cope with that?
Thank you. Before you ask, can you ask any other last questions? No. So 1 and 2. Please.
We can't leave without following up on the singularity bait that was thrown out. Everything you've described until now is a technology that is incredibly stupid, but very specialized. It's very, very good at a very particular task and has nothing to do with general AI. As I understand the singularity discussion, there is a leap of faith of dimensions as to whether we can turn this incredibly specialized tool into a kind of general system thinking that provides superhuman intelligence. What is the future of this field? What are the leaps we're going to see in your view? Because this becomes obviously almost a theologian question in this realm. I understand it's, but give me your best or worst.
You are
predictions.
privileged to have the last question.
Okay, so as I was saying, I'm a master's student. I will be finishing the next couple of months. And I have also colleagues and friends sitting here during the program. During the year, we were studying cybersecurity is so important, and this is how going to be the future of counter-terrorism. But we were also being told so many times as the students from the social science fields, you are not going to be able to really research these things because your knowledge is limited. So like they're showing us how important it is, but not telling us how to do it ourselves. So do you think that we should, as even though we are from social science, that we are forced to study computer science or more technical, or have more technical knowledge, or do you think that perhaps it's more relevant for Dr. Woodard, right? And Mr. Omri, do you think there are positions, or we are going to be able to like join the workforce with this limited knowledge of only social science?
So you're basically recommending to change the IDC curriculum in order to... Yes.
I'm working on it.
Yeah.
I fully support that.
Sure. Noted. Yes, please.
I think part of the thing that the ICT and IDC is doing very good for this kind of thing is the internship program. When you go to a company, so at the end there is a big difference between the academic work to the real life of the real R&D companies. And this is the mechanism that I think they're doing over here very good, this program, to do internship in such kind of companies to understand what is the cycle of R&D and how does it work. And then from the tools that you learn, it can help you after that. Because for me, as an entrepreneur in the last 14 years, the most important thing is experience. Even if you didn't care from the background, today we need people that are willing to work hard and to understand this is a hard work. It doesn't matter where you came from, and this is more important than everything. And this program is giving you to understand that working hard. It's not only coffee, massage, and good salary. We're working very hard as well.
It's not only, huh?
Not only, but very important.
Yes. You can pick up any of those questions, of course.
I'll address 3 questions, if I may. Start with your questions. We saw a question. Yes, this is a challenge that we are facing now. We're in the, as I also mentioned, I call it interpretable machines. That in order to the analyst to trust the machines, we have to interpret and say how and why we got to that conclusion. We have some POCs this area. It's easier when it's machine learning, not involving the deep learning. But there are also new areas now in deep learning that explains not exactly, you don't have to explain exactly the specific feature, but explain the trend or why the machine decided that. We're in the beginning, but it's a big challenge, and I think it's a phase that in order to get to the what I call the version 2.0, we have to go through that. Otherwise, the data analyst won't trust the math of the machines. So. If you have any work on that being done, we'll have to hear from you.
Speak offline.
Okay. But your question, it's more a philosophical question than science, and this is this is my next degree after I did all degrees in computer science. This is what the philosophy is what I want to do. So, but if you're asking me, because you still asked, I don't see the future so pink. I see it. I'm not sure it's a world I want to be living in 50 or 100 years. I think all what we can't even imagine what's going to be. But I think basically we're going like maybe 1,000 years before, when you had the lords of properties, and you had the people who worked and worked on the ground. So I think it's going to be pretty much like that. I don't know if data scientists, but the people, organizations will rule the world, and it'll be very different, not only in the salary, it's to be in everything. I mean, with AI, you can create a person that will live longer, that will be smarter, and more beautiful, whatever. You can really, and it will be the race will divide to two. And not 50-50, it will be 99.99%, and the 0.0%. That will be, it's everything, the lives will be very different. This is my, my perspective.
50 years.
I don't know, I would say
You're sure machines won't rule the world, but we will?
Or that. We already talked about that, all right? There'll be maybe no human beings or that also, but I don't know. That's my area. And your question is very interesting, because what we're doing now, this is how I got to know Professor Ganor, is that we start talking about that we have to change the curriculum, specific IDC, but not only, and we have to bring
data analytics.
Yeah, but in every area, law, medicine, economy, and you name it, has to be a few courses that are teaching all these people machine learning and statistics and high level, etc. So they'll be able to work with machines, teach the machines, because this is what's going to be out there in the industry. It's already now. It'll be much deeper and more various in the next years. What I think will be, not now, but in maybe 10 years or maybe less, that should be a degree that is data analyst. And your profession will be data analyst, and you only will take a few courses in economy or medicine or law in order to be a lawyer or forgive me. But this will be the profession, and the domain experts will be like a few courses.
Yeah, and don't lose hope. Because no, even if IDC doesn't implement this before you're finished, I mean, a lot of the things that I explained, you can find tools online, you can find libraries, you can learn how to do machine learning or program or do the basics of data analytics yourself. I mean, there's tons of stuff out there that you can actually start with. So actually, we are doing that with law enforcement agencies, teaching them how to use tools that already exist at their disposal to kind of do these sorts of things. And those profiles are social science profiles or criminal justice profiles. They're not technical profiles.
Perhaps before even teaching machines how to be human, just an anecdote. When I started my studies 20 years ago, I wanted also to go to learn philosophy. I ended up with law, 5 degrees, 4 in law, because the common knowledge back then was that it's philosophy is not pragmatic, is not practical enough. But in the last 2 years, we are witnessing that the big companies, Google and Apple and Microsoft, have hired senior professors from Harvard, from Stanford, to do ethics of philosophy of technology and ethics of technology. And while teaching machines how to behave, before we teach them laws and rules and how to regulate that, we also need to reflect on the very philosophical and ethical considerations that we want to achieve. What are the goals? What are the method of evaluation? And I would assume that if we had data analysis, we should definitely have some people who do ethics of technology and philosophy of technology. Mm-hmm. So unless you have very urgent things to say, let me...
We didn't answer.
We didn't. Yeah, but I cannot answer the... Huh?
Google, you asked about Google.
Yes.
Oh.
So is anybody accessing Google data or?
It's a complicated question with a complicated answer. For general, yes. As Reed said, most of the big companies are using better intelligence agencies today than even some governmental agencies. They have access to all our data, our users, because we give the consent to them to use the data. But the data is protected by law. Okay, my data as a user in Google is protected by law, privacy, and depends, of course, which law the specific company is applied. And we are, as law law enforcement, sometimes we have an access to a very certain segments of the data, but it is all by, for example, a warrant, okay? Because if we need to get an access to a data that is protected by law, we need to convince the judge or whatever mechanism it is that will allow us an access. I can tell you that most of the time, it's a very limited access. I mean, if we have, and it really depends on the case, okay? So it depends on the case, you get a different type of access to another segments of the data, but it is more limited than you can think, okay? We never get full access to the entire data that Google, for example, Facebook has on a specific topic that we're interested in. Okay, what do you need? What we are able to give you? For several reasons. First of all, they do want to protect their users, okay? And by the way, they want to protect themselves because they're obliged to the law. If they will give information, even to law enforcement, that they are not allowed to, they may be sued.
But there is a field now that's called editing. That's by advertising that you can collect a lot of information from people as well. It's used by Google. So this is a field that is going very fast and developing to companies to try to give law enforcement additional tools to make this information more accurate.
Any last points? So please join me in thank you for all the panelists for fascinating work.